He is an organizer for the Data Visualization and Data Engineers DC meetups and the executive director at Data Community DC, a 501c3 nonprofit dedicated to data education in the National Capital Area. I am so excited for this talk. Please join me in welcoming Will, and we will get him hooked into the AV system.
Hello, everybody. Let's see. I think I have my dongle. I do have my dongle. Very good. Should be good, I think. So let me get everything set up here.
Amazing. And I will flash you a 5-minute warning in case you get so caught up in this wonderful conversation that we lose track of time.
Sounds good. Sounds good. All right. Let me see if we can get slides up and running. Choose to, let's do the entire screen. All right, very good. So, can I get a quick show of hands? Who here has used DuckDB? Nice, couple of hands, great. Who here has used Pandas? Even more hands, awesome. I'm here to share some good news. This is doing the speaker view. Is there a way to not do speaker view? Who here knows how to use PowerPoint? Yeah. Come talk to me. Go. Oh, this is the wrong one. Can I switch this? Oh, I'm on the wrong screen. I swear I know how technology works. Yep. So, what's that? You're right. So, slideshow.
I'm going to be so unhelpful with this.
I know. Slideshow.
If anyone knows faster than I do, give a shout out. So go back to the share.
Back to here.
Oh, yep.
Swap
display. Yeah. Slide up and over.
Oh, slideshow.
Yep, and then go over to the right. 1, 2, up. Swap displays. Turn that. Yep.
Hey, very good. Cool. It's way up there. All right. So today I've got a couple of cool things to tell you about DuckDB, and I'm going to give you my key points up front. One, a fact. DuckDB. This one backwards. DuckDB is an MIT licensed embedded analytical database. Keep that in mind. Second fun fact is that it's really easy to go back and forth between DuckDB, Pandas, polars, all that good stuff through the magic of Arrow, which you just heard about, a lot of the details that make that possible. Based on those two facts, I have a suggestion for you. You should consider using DuckDB for your data processing and analysis. And then the last key takeaway is that I have an argument that you should seriously consider trying DuckDB before going to big data tools. And I'll get more into that towards the end. But first, hi, I'm Will Angel. I like ducks, do some wildlife photography for fun. I live up in DC in Arlington. Like was said, I help run meetups through Data Community DC, and I am a data consultant. So I do this stuff for money, and I help a lot of people wrangle with large data tools that they probably don't need, thanks to tools like Arrow, polars, and DuckDB. So today we're going to talk about what is DuckDB, why you should care about DuckDB, when should you use DuckDB, how you can use DuckDB, using DuckDB in Python, data processing, performance, and profiling, got a few benchmarks, a little tangent on the shrinking of big data, and I will have some demos as well. Also, I do have some ducks, so if anyone wants some help debugging, I've got some rubber ducks, and I think a few googly eyes in the bag too. So if anyone asks a good question gets a duck. So what is DuckDB? So DuckDB is an open source, fast, in-process analytical database. So open source means it's free and open. It's MIT licensed. So you can use it for commercial purposes. You can download it. It's great. It's fast. So DuckDB has been built with the last several decades of database technologies. So it uses things like implicit SIM, SIMD, column-oriented things, all sorts of great stuff to make it really utilize compute power effectively. And that means it's fast, it's performant, and thus you get a lot more compute per CPU cycle, per dollar, all that good stuff. It's in process, so this means it's like SQLite. It runs locally without a server. So you don't need to spin up like a ClickHouse instance or Postgres. It runs there in process. It's analytical, so it is oriented for analytical processing, so lots of large aggregations and all that. And that means it is not good, or well, it still works, but it's not as fast at like single row reads, single row writes. So if you want to do transactions, you're better off with something like SQLite. And last, it is a database. So it is a way to efficiently store relational data. It's not going to be as efficient as an actual file format as something like Parquet, but it's going to be significantly smaller than storing your data as a CSV. So why should you care? Well, I have ducks if you care. So DuckDB is a great tool for doing local SQL analysis. You can just bring in a file and do SQL locally. You also can use it to import and export data well. So if you have a CSV that you're having trouble getting into Pandas, give DuckDB a try. They've put a lot of work into the ergonomics and the CSV import, so there's a good chance that it will work better there. And that makes it really good for just pipelines and wrangling data, getting things into the right place and format. Another cool thing is that DuckDB is really starting to power a new generation of embedded analytical tools. So you've heard a little bit about how Arrow is making some of that possible, but a lot of new websites and things and tools are going to have DuckDB in the browser powering like real-time analytics there through the magic of WASM and all of that, WebAssembly. So to get a little bit more technical about why you should care, so DuckDB, it's like SQLite, but for data processing. And it's really, really good at that. So just like SQLite, you spin up SQLite, you have a database, magic. DuckDB is like that, but it's a data warehouse. So it's very convenient in that regard. And if you're building systems, if you're also, data engineer, software engineer, instead of going and getting Snowflake to power some application, you might be able to get away with using DuckDB. So worth considering. DuckDB is versatile and fast, and it's competitive with Spark or Polars in benchmarks. I'll get into that in a bit, but it really depends on what you're trying to do and what you're trying to benchmark. DuckDB is also portable with 0 dependencies. So they do have a couple of dependencies in their actual source code, but they vendor those in, meaning every time they go to release a new version, they take their dependencies and they put them all in the source code, and they take full ownership of that. So you get a binary, pip install, however you want to get it, and you don't need 10,000 dependencies. So it's pretty great in that regard. And another reason to care, now I heard a great quote earlier today that tools that build upon Apache Arrow are expected to yield significant reductions in non-value added data engineering. And that phrase, non-value added engineering, really stuck out to me, and is actually a much better way of phrasing the entire core point that I'm trying to make today, which is there's a lot of incidental effort and complexity that goes into doing data, and good tools mean that you can focus on the essential complexity of your tasks, of your work, and really focus on the data, the business, the value, the stats, whatever it is you care about or are getting paid to care about. All that non-value added engineering and effort gets in the way of that. So good tools like DuckDB, I think, really help with that. So when should you use DuckDB? If you like SQL, who here likes SQL? Yay! Use SQL like COD intended. Couple of people know their history. If your data is getting medium large-ish, and I'll define that a little bit more rigorously later, but at a certain point, Pandas is a lot better than it used to be about running out of memory and not needing 5 times as much memory to actually hold data. But if you have enough data, using Pandas is going to get slow, it's going to get painful, and you can use DuckDB to be more efficient at that. And then if you're getting to a bigger scale than that, you may start talking about things like Spark and getting distributed computing clusters, and all of that is a hassle, and that means time, that means money, and I will make the argument that DuckDB, as well as some other things like polars, will allow you to defer that investment and all of the pain and cost that comes with that for longer. So if you're thinking about going to Spark and needing to get hundreds of compute nodes and all that to do what a laptop can do, consider DuckDB. So how can you actually use DuckDB? And I'll show you these as well. So there is a DuckDB package in Python that has bindings. It's a wrapper for DuckDB, and you just bring it in and can use it. And it's got great interchange with pandas, polars. IBIS uses it, and so it is a really good way to just use it. That's thanks to the magic of Arrow, of PyArrow. And within Python, one thing to consider is you can use DuckDB as a backend for a data app using something like Streamlit or Gradio, and they have a lot more real-time data processing capabilities that you can then expose directly to an end user. So that's one particular place where it's potentially really cool. So instead of doing all your data processing in advance and then hoping that that's the right thing that your end user wants, you can give them the power to do that and actually change how they're aggregating data. So there's also a command line interface for DuckDB. You can open it up in a terminal, do things that way. That's pretty cool as well. It's pure SQL and all of that other stuff, so that's not as Pythonic. They also have a DuckDB user interface, which is still experimental, but it is actually pretty cool, so I will show you that as well. And it's just the DuckDB command line interface with the -UI command, and that opens up the UI locally in a browser. That UI is based on MotherDuck, which is a data warehouse company built around DuckDB. So they're doing pretty cool things to try and make the DuckDB to cloud experience seamless and awesome. So I'm really excited about that because ergonomic data tools, I think, make us all happier and more productive. So before I get into the demos, I want to talk a little bit about performance and DuckDB versus pandas. So with that, I have a benchmark. I made this one. There will be more to it, but as you can see here, the legend's actually pretty good up there. We've got, we're doing a group by aggregation here on differing file sizes. Each data point represents a record of runs, and you can see that I did it on a couple of different data sizes, all the way up to 100 million rows. And that's about 5 gigabytes of data here on the big end, and about 300 kilobytes on the small end. And you can see that until you get up to about 1 million rows, Pandas is very competitive. But as you get to 100,000 million rows, Pandas starts slowing down. And then when you get to 100 million rows, Pandas takes 50 seconds to do this aggregation, whereas DuckDB does it notably lower, and it's like 2 or 3 seconds. I will note polars is competitive here, and a lot of it depends on what exactly you're trying to do and how your data is structured. So with benchmarks, it's hard, and a lot of it, again, really depends on exactly what you're doing, the hardware you're running it on, if you have other things going on, if you really want to convince someone that your tool is faster than everyone else's tool. So there are a lot of places where benchmarking is not a conclusive story. So I'm not going to say DuckDB is always fastest. I'm not going to say it's always best, but I'm going to say it's almost always going to be more performant than Pandas. And again, if your data is small, if Pandas is working for you, keep on using it. Like, it's a great tool in many regards, and if it works, like, you don't have to switch. If your tools are good enough, they're good enough. But if you can use good tools, they're better than bad tools. So I'm going to go off on a brief tangent before doing my demos. So, who here works with big data? All right, how big's your data actually? It's a safe space here.
Sounds like a personal question.
All right. Say no more. Tons of terabytes. It's pretty big. All right. So, as I was putting together this talk, I came across a quote from the CEO of Fivetran, George Fraser. Who here has heard of Fivetran? Oh, okay. It's like a low-code data integration tool. Expensive, but very good. Part of the sort of modern data stack and all that good stuff. So basically, he was doing benchmarking and found that DuckDB, like in the configurations he was testing stuff out on their server, would lose to Spark. It would lose to Polars. But found that on his MacBook, which was actually more powerful than the server, it outperformed them all. So I think that's one thing to consider, is just modern hardware is really powerful. And even if you have, like a kind of mediocre corporate laptop, if it's within the last couple of years, there's a good chance that it's still got, 8 or 16 gigabytes of RAM, a pretty good, CPU, and if your data is smaller than RAM, or within a few factors of 10 of your RAM, you can get away with doing a lot of local processing. So computers are getting bigger. So this is a graph of the historical cost of computer memory and storage. And 2014 is when Apache Spark was introduced. I'm going to say that is what I would say is like one of the defining technologies of big data, coming out of Hadoop and really making big data more viable. And if you disagree, I'd love to talk more for Duck. Since the introduction of Apache Spark, costs have kept coming down. And this is a logarithmic chart, so it is significant. And memory has gotten cheaper as well. So since 2014, RAM has gotten 80% cheaper, which means you get significantly more memory per dollar and can also just get access to more memory. So if you want, you can go onto AWS or the other big clouds and rent a server that has multiple terabytes of RAM. And it's like $100 an hour. It's not cheap, but that's actually still really cheap, because that means if you have, a terabyte data set, it fits in memory if you're willing to buy a nice computer. So it's worth considering before you need to go to big data technologies. And I think that we're seeing a world where there's a lot more annoyingly medium data. Doesn't open in Excel, so your business friends are like, hey, you got to help me with this. But it will fit in RAM on a decent laptop. And as laptops are getting more decent, I think we're seeing large language models accelerate that trend where now, if someone wants to say that it's an AI laptop, an AI computer, they probably need to give it at least 16 gigs of RAM, maybe more like 30, maybe a nice GPU. But because of that, I think that we're going to be able to defer investing in large-scale distributed systems like Spark. And Spark is a great technology, but it's also kind of a pain in the ass. And if you don't have to deal with that, why deal with that? So, with that, I'm going to move on to demos, but I do have some ducks taking a nice bow there. So, let me go ahead and move this over here. So, I closed my terminal. That's fine. So, go ahead and put a terminal. And so here I've got a Jupyter notebook, and I'm going to go ahead and import DuckDB. Actually, I was about to say, can y'all read that? Cool. So I'm now going to use the duckdb.sql function to run a SQL string. I'm going to select star, select everything from this CSV file that I downloaded earlier, and save it as data. So I'm going to run that. Now, data here, this is fun. The data here is actually it's not yet a table, but if we do this, because again, DuckDB is very ergonomic, it will just give us some nice data. And it's pretty well printed. I think DuckDB tends to do a better job of displaying data than some of the other tools that you may be familiar with. Now, for folks who are familiar with databases, you'll know that most databases have some type of describe function that will tell you something about a table or a schema. One thing I want to note here is that when I run this, it will fail because we have not actually made a table yet. DuckDB has read that CSV in as a temporary table. But except for some of the catalog metadata things, we can still treat it as if it was a table, temporary table. So DuckDB has a very useful summarize SQL function. And who here likes doing exploratory data analysis? So you're probably familiar with some summarize features, and it gives us some nice stuff. So we can see that this data is about the Virginia economic activity per quarter. So from 2005 to 2019, and there it's got a record per quarter and has like millions of dollars of economic GDP and all that good stuff. However, this is this is decent summarize. I'm actually a bigger fan of Pandas's describe function. So I'm going to convert this to a data frame. Now we have a Pandas data frame. And I should now import Pandas. And then I'm going to use the Pandas describe function. So again, this is now a Pandas data frame. And this one-liner here is one of my favorite exploratory data analysis techniques because it rotates it sideways so you get to see all the columns and has all these nice statistics. So very helpful for seeing, if you have unique values, if you've got null values, all that good stuff. You can see that there's only one geo name here, so this Virginia, that column is not very useful in this data set. So if we wanted to, we could also use DuckDB to output to Parquet. So you can just go ahead and do that as well. Save it as Parquet, very easy. And it's very easy to go back and forth as well. So if I wanted to convert this back into a DuckDB table, I could then, well, you can use Pandas to output to Parquet as well. I've found that the default settings in DuckDB tend to be a little faster and a little bit more compressed, but it is possible to configure them both in very similar ways. So I want to go back to that graph you remember of the benchmarking. That is getting saved into a SQLite database. So I'm going to go ahead and install a DuckDB extension. Now, DuckDB has a set of extensions. Some are official, some are from the community, and they're basically anything that you can do in C, you can use it as an extension in DuckDB. And so there they have a number of very, very useful extensions for making data stuff more useful. Some of them, like SQLite, are just interfaces for the actual libraries. So in this case, I'm going to install these, and then I'm going to read from my SQL database here, the SQLite database, and read from the benchmarks results table. I'm actually going to officially create a table here. And now I'm going to select star from that benchmarks table that I just made, and in one line pass it to Pandas, and then use the describe and transpose function. And so we now have all of this right here. So you can see that this is our benchmark table or summary statistics on it. And we've got a couple of different operations and different things. The interesting thing to note is the execution time is in seconds, and they're max of 56 seconds and a minimum of 0.00003 seconds. So depending on data size and tool, some things are faster than others. So one thing that I wanted to do is I actually made that graph and then realized that I should add more things besides just aggregations. So I decided to add some filters. So we're going to go ahead and do a little bit of data preparation. So we've got this SQL statement. Also, one thing that's really fun here. DuckDB has a lot of quality of life SQL syntax things. They call it friendlier SQL. And you can put your from first. So if when you write SQL, you're like, why do I have to select all my stuff and then do from? With DuckDB, you can actually do from table select. And they've got a bunch of other fun quality of life things there that I think are really nice. So we're going to, from our benchmarks table, select the tool that was used for the test. So pandas, DuckDB, polars. We're going to have the file size. When doing some of the benchmarking, at one point I had I'm not going to call it a bug, more of an unhappy accident, where I had some of the runs, like the operations, those tests that got the run number appended to them, and rather the run iteration number appended to them, which doesn't actually tell us anything because we want to compare all the runs to each other, because I was doing multiple runs per test. And so here I'm going to use the DuckDB's regex replace operation and get rid of the last integer character and replace it with a empty space. So if there's a trailing integer, this will remove it. We'll get execution time, and we're going to turn it into a pandas data frame. And then we're going to do a visualization. So here, Seaborn, matplotlib, all that good stuff. And we will go ahead and run that. And this is going to generate our new updated chart with the additional records that I did. So let us see how we did. Oh, interesting. So we can see that pandas, again, as we knew, as the data gets bigger, it gets slower. Clearly, I must have messed up my benchmark, because DuckDB, I would expect to be a bit faster here. And you can see that on the actual aggregations, it is still real fast. So I've probably messed that up. Or maybe for this kind of filtering, the polars could actually be faster. But I think that if I'm actually testing the same thing, those should be the same. So I'll have to look into that. So this is, yeah, good fun. How am I doing on time?
You have 8 minutes.
8 minutes, awesome, cool. So one thing that I will also note is there's a HTTPFS extension for DuckDB. This is from the official maintainers, and it allows you to do web requests. And that means that you can actually, instead of reading from a local file, you can read from a file on the web, or read from, pull in a DuckDB database that's stored, say, in cloud storage. And what this means is, in theory, because of how you can chain things, you can do, read CSV from the web, write to Parquet. So you can have a one-line data pipeline with DuckDB. Now, I'd recommend probably maybe splitting this up, doing some like logging, monitoring, error stuff, all that good things. But this is a 800, almost 900 megabyte file for the state of Virginia's procurement data. I'm not going to run this on the Wi-Fi here. Also, it'll take a couple minutes, but you can do with DuckDB one-line data pipelines. Should you? Give it a try. But you can do things like this, which might be a good first step in your data processing pipelines. As I pull up the other demos, does anyone have any questions?
How about we start right?
Oh, yeah.
I'll call it out while you
Perfect.
do the demo.
Thanks for your demonstration and your presentation. That was really good. Just one question. Does DuckDB support any data types that are maybe different, like Postgres, Oracle, or relational databases that are very popular?
Ooh, that is a good question. I don't know of any data types that it doesn't support that they do. It is based on Postgres, so it is pretty close to fully compatible with the Postgres SQL. I think there are some places on some of the more like transactional stuff where it's not 100% compatible, but in general, if you can do it with Postgres, you can do it with DuckDB.
Does the Python SDK have any sort of query
So there is actually a relational API that DuckDB uses under the hood. So it takes SQL and translates that to a relational API that's using like relational algebra. And so there, if you want, you can actually directly use that. And there are some tools that DuckDB uses to hook into DuckDB via that. That's a good question. So while someone thinks of another question, this is the local DuckDB user interface. And you'll note it's in large part maintained by the people from MotherDuck, so it's kind of a, like advertisement for their stuff, but it is free and pretty cool. And basically you can import files or attach databases and all that good stuff. So what I'm actually going to do is go back to the database. I've got this benchmark results database. I'm going to copy the path. I'm going to add a file. So this is just the SQLite database. And it's going to import that as a database. And you can see we've got our nice little explorer here. So we've got benchmark results. And it gives us some nice, fun little summary statistics here. You can see we've got things going on. And then it also has support for SQL notebooks, which, fun fact, you can also do with the with some of the Jupyter extensions. So I'm gonna select our database here, SQLite. Though again, this has been imported and is stored as a table within DuckDB. So we can select star from, what was it, benchmark results. It's got nice auto correction. The interface is a little goofy when it's zoomed in like this, but you can see that we have these nice little histograms and things. So we can see, if we want to look at what the file size is, this is in megabytes. So 4,000 megabytes is going to be gigabytes. And you can see that the records that I tested nice round numbers of things. So it also, the user interface has a fun thing where you can do pivot tables just in the UI. If you don't want to write a group by statement yourself, you can do that. So there's that. And then there is also, let me make this bigger. You can just do DuckDB for the CLI. Oops. There we go. Hey. So, questions?
Yeah, so we've seen you use CSV, Parquet, SQLite. What is the best file type to use with DuckDB, and what is your favorite file type?
Ooh, great questions. So one thing that I have omitted from my talk for time purposes is that DuckDB does have its own database format, so you can actually save things as databases. And there, that is great if you want to have a database that you can basically save and work on. As far as what format is best, depends on your use case. With Parquet, it's really good. Parquet is a great file format. You can also use Delta or Iceberg, where it's Parquet plus a metadata catalog format, and there that allows you to do a good mix of the power of Parquet plus the more actual table format of things. I usually like Parquet or just using the actual DuckDB databases. But again, depends on the use case, and some people have done really cool things using DuckDB as a lakehouse execution engine. So instead of having to spin up a Spark cluster or use Databricks, that kind of thing, if you have data lake file formats in the cloud, you can just read those directly from DuckDB. Do I have time for one more question?
I don't
No.
think we do.
All right. Come talk to me afterwards. Get a free duck.
Guys, thank you so much.